Hello and welcome to the Unserious Science podcast, the podcast where we talk to LGBTQ plus scientists, experts, and get them to explain to us something misunderstood, misconstrued, or just weird within their field of research. I am one of your co-hosts, Dr. Rebecca Smith, aka Bex.
I'm Dr. Eleanor Townsend, disaster bisexual and microbiologist.
Lovely. Is that just your tagline now?
Yeah, I do. I like it. I'm sticking with it.
Okay, perfect. I didn't define myself, but that's fine.
Yeah, I think the first time I did it, I said I was chaos bisexual, and then Dan asked me, like, is that a thing? Is that like a specific thing? And I was like, nah, it's just
you.
It's just me.
Lovely.
Not very spicy.
Well, I'll hand over to Ellie to continue the intro.
And we have tangent already. We have our first guest speaker, which we're very happy about, and we have the lovely Claire, who is the founder of Prism Exeter, which I'm hoping we'll hear more about later on. But Claire, if you want to introduce yourself.
So I'm Claire, use she, her pronouns. I am a physicist, I suppose specifically an astrophysicist, so studying like space and all that kind of crap. I normally joke, and some people probably get tired of hearing this joke, but I normally joke that I identify as like a gay lass because it has the bonus of, I suppose, outing myself as northern as well as gay. So
so many closets to come out.
I know, right? But I use the word queer as well, so I kind of like that word too.
Yeah, we love the word queer here.
Yeah, we are on the queer train.
less chaos in my direction, though, I think.
Yeah, you're very organised, Claire.
Well, okay, if I appear organised, then maybe I just kind of have a screen for the chaos.
Oh, okay.
You should introduce what your topic is going to be for today.
So do you want me to kind of express it as in the thing I'm kind of like disappointed in with like how the media represents the certain thing? Like
however you want to go about it.
I like the strong word of disappointed. It's like I'm not angry, I'm disappointed.
Yeah, I can do that whole like parental thing. I think that kind of like works because like I have to caveat what I'm about to critique by saying that I'm a big fan of Star Wars.
Me too.
Okay, it's a collective agreement with that. That's good. But it has always annoyed me, frustrated me, disappointed me, that Han refers to the speed, I think he's trying to do, that the Millennium Falcon can go as doing the Kessel Run in 12 parsecs.
Yeah.
And the parsec is a unit of distance.
Yes.
So the entire statement doesn't make any sense. You can't interpret it as a speed.
It would be like saying I do Exeter to Plymouth in 40 miles.
Exactly.
It doesn't, it's not, it's a statement of fact.
That's how long it is.
It doesn't matter if you go 2 miles an hour.
Even if you try and figure out that, maybe they were, going at light speed or something so you could convert it. It doesn't even work as a conversion. Like it's such a strange statement, and I don't know,
So what is a parsec?
Long-winded answer?
Yeah, go.
Yeah, okay. So a parsec is a unit of distance. We're getting that out of the way already.
Putting your foot down.
Yeah. So the easiest way to look at parsecs is to think about parallax. Okay, so has parallax come up? Because parallax is kind of met in the everyday world, but isn't really used as a word.
It's a word I've heard, but I don't think I could define it.
Okay, so the way it's used in astronomy, parallax, is to imagine like a triangle, and you've got the Earth's orbit around the sun as the base of that triangle. Okay, so you can imagine 2 months that are 6 months separated, and that would be the Earth at either side of the sun to form the base of that triangle.
Okay, perfect.
Okay. So then you imagine that you're looking at the same star. Let's pick January, and let's pick the other side July. So you look at the same star in January, and you look at the same star in July. And the angle that you would be looking at it at those 2 different months would form a triangle towards that star.
Yes.
And the star will shift in relation to stars that are further away from you. So just as if you're like traveling on the train or whatever, you can see the foreground moving at much faster speed past you than like some hills or whatever in the distance. Similarly, if you're riding your bike, the streetlights go past you faster than the buildings that are slightly further away. And that idea is your whole parallax. It's that movement of different things at different distances from you by different amounts in an angular sense. So then a parsec has some numbers assigned to it. So it's a measure of the parallax, or parallatic angle. So if you've got that Earth-Sun distance at the base of your triangle, and you've got a star that is a parsec away, then the angle that subtends, I appreciate subtends is a specific word as well, but the angle in that top corner of the triangle will be an arcsecond. So it's that one astronomical unit, which is the distance between the Earth and the Sun. 1 arcsecond is 1 parsec. Yeah.
Oh, okay.
Yeah, but again, I've introduced arcsecond. So this explanation is just going on and on and on. Okay.
I've defined a term, and then to define that term, I must define another term.
I know, it doesn't. Yeah, it's turtles all the way down. So an arcsecond, if you take a degree, which is about the same distance in the sky, or the size of the sky, if you take your little finger and you hold it at arm's length, that's covering up about a degree in the sky. An arcsecond is 1/3600th of that, so it's divided by 60 and then divided by 60 again.
Okay.
So you angles kind of use units like a clock. So you've got 60 minutes or 60 arc minutes in a degree and 60 arc seconds in an arc minute.
That's nice.
Yeah, because there's a nice kind of similarity between 365 days a year and 360 degrees in a full circle.
Yeah.
So that kind of distance and angle all matches up. It's quite nice.
That is very cool.
I appreciate that. As soon as you talk about astronomy, you're looking at big numbers, and so you're saying numbers again, and divide this really tiny space by this number of digits. So I did have a look up about what I could compare it to.
Oh.
So if you imagine sitting at the side of a football stadium or a rugby stadium,
Yeah.
or the end of a tennis stadium, if that's your preferred sport, and looking either along the length of the tennis court or along the width of the football or the rugby stadium, then an arcsecond is the size of a human hair. So that's the angle that it subtends at the other side of that sports pitch.
Yeah, I think that. So I think where.
So whichever of those you'd find easier to picture.
I mean, it's good. It's good to have a reference point of the difference in scale. I guess I feel so. I've not into super into physics, but I've watched a lot of astronomy stuff.
Yeah.
And I remember watching something once where they were talking about the distance between different objects in space, and I felt physically sick trying to imagine the vastness of space, and it was just oh my god, I'm so swimmy, and it's very weird to have to fathom that, I guess.
Yeah, I find people have one of two reactions to kind of the enormity of the concepts that you deal with in astrophysics, or some of the small stuff that you deal with in physics, and that's they either whelmed or overwhelmed.
Yeah, overwhelmed, definitely.
And I don't know if whelmed is a statement, but it's I'm kind of matter of fact that it's okay, that's a number, I'm accepting
that's
of that.
That's a fact, yeah.
We can go through with that, that's fine. Or they're just whoa!
Yeah, that's me. I think I made that noise.
Direct quote.
Yes.
So, with light speed,
Yeah.
is it possible to go faster than the speed of light currently?
It's not theoretically possible.
It's not even theoretically possible.
No, I mean, there'll be some theorists who are trying to find ways to manipulate the mathematics to say, in this realm it could be possible, but it's whether that realm even exists. Because
that's what they do in Star Wars, right? When or is it hyperspeed?
They go to hyperspeed.
Hyperspeed.
Yeah.
I don't know if it's ever defined about what fraction of because I imagine therefore they're assuming that they get up to a fraction of the speed of light.
All right, fair enough. They can have that. We'll take the parsecs back, but they can have the hyperspeed. That's allowed.
Yeah.
Okay.
But it's this problem that you've got Einstein's famous equation, which is the E = mc squared. Okay, and even if you probably just know the equation, you know that as E = mc squared.
Yep.
So that E is referring to energy.
Yeah.
The M is referring to mass, so something's weight, and C is referring to the speed of light. So if you are transporting a mass close to the speed of light, then you've got the square of that speed of light in the energy that's needed to transport that mass. So, and the speed of light is a number that ends with 10 to the 8.
I'm getting overwhelmed again.
It's a very large amount of energy.
So basically, theoretically, even if we could get to the speed of light, you would require so much energy to be able to do it, or it's just not physically possible in any realm of being.
Let's get into a fraction of the speed of light.
Yeah,
it's not. But you're looking at almost infinite amounts of energy to put something to and keep something at the speed of light.
Fun.
Whereas photons, which are the kind of particles that carry light, they're the light particles, they have no mass, which is why they can travel at the speed of light.
Sneaky.
Yeah.
Those sneaky photons. Like it just takes me back to Star Trek instantly, because I'm like, they never go the speed. Like there was like, oh, this ship can go like 0.9 speed of light, and that's like an amazing. Obviously, it is an amazing feat to be able to do it. But they always talk about things in relative to the speed of light, and it's always like, oh, 0.9, 0.8 speed of light, and it's great.
So even like something at like 0.9999999, you're still not at the speed of light. And these would be the accuracies that like to the level of like being at 1.0000000 or whatever speed times the speed of light that you couldn't get to. I'm not saying that you couldn't rule out getting to like 0.99 recurring as you much want to times the speed of light.
You're never going to get to the full one.
And I think it brings you back to that kind of like, just because you can doesn't mean you should argument as well, because if you're using up that amount of energy,
it's irresponsible.
Yep.
Yeah. Okay. I mean, sometimes it's fun just to like see, but then maybe you should put it towards something more rather than like brum.
I mean, as soon as you've set it off, I mean, you're not going to receive any messages back
after it.
It's gone. No, you're right.
Gone.
No, I'm seeing this. I'm like,
it's like the world's worst firework.
It's gone so far, so quickly.
Even worse than those ones. Like,
oh, those are my favourite fireworks.
What?
Yeah, I really like the noise. It scratches my brain. I just like it. I know we spoke before about the difference, because you're talking about numbers on like a very, very large scale.
Yeah.
The
angle's got quite small, but yeah.
Okay.
But carry on with your point. Sorry.
But I mean, the angle is small.
Yes.
But the distance is far.
Yes. Yeah, definitely.
Yeah, and that's why the angle's small, right?
Yes. Yeah.
Okay.
I'll do a little fist pump of like yes, because that means the explanation worked.
Yeah. I'm just really smart, Claire. But I know we spoke before, because we sometimes use electron microscopy to look at things that are smaller than the wavelength of light, so things like viruses. But then you use sort of electrons and things to look down telescopes in a very different way, right?
So we would measure electrons, but we would be observing photons. So what happens is your light particle enters the CCD, so your charge coupled device in the back of your camera, and sits in what's called a potential well, and then you flush out they're kind of recorded as electrons. You flush out the electrons and you get your signal in each of your pixels. So there's kind of like a synergy between your photons and your electrons, and just the receiver versus the measure. Yeah.
I just think it's nice that all these things sort of link together, and you do feel very small in the universe.
I quite like that though.
Yeah,
there's a comfort in being insignificant.
Yeah.
Yeah.
Yeah, that's right.
Whereas I think some people feel a bit afflicted by that.
I don't think it's about insignificance. I think
I really do feel comfort in insignificance.
That's sad.
Why? But it's not, right?
Yeah.
I'm saying like for me, I don't think it's about like the difference between being like significant and insignificant. And like I have no issue with being insignificant in any way, shape, or form. I think like in my mind, I'm just sort of imagining like the physical action of traveling or being in that amount of space. And just like looking or being in any direction, just there's nothing for like billions, millions of miles, like that kind of...
That's really interesting.
Yeah.
Then, because one of the active areas of research on Earth is to look at the mental effects of astronauts going to Mars, for instance. Like, it's pretty easy. We've been doing it for a while, putting astronauts on the moon. Not going to listen to any haters on that content.
No, it's quite pro moonwalkers here.
Yeah. This is so last episode we covered being pro vaccination.
Yeah, there we go.
We're like pro.
We definitely went to the moon.
Yeah.
There we go. But the psychological effect of not necessarily getting somebody to the moon, but getting them back from it, is something under active investigation. So there are there's camps in the US, for instance, where they've done psychological testing on people. So it'd take about 8 months, that journey. And that's not including the time spent on Mars or whatever. So there's been some like suggestions that it would be prepared for as a one-way trip, for instance, because of the psychological effects of the return trip being so stark. And so these are kind of like the discussions and complications of those kinds of missions. So you're not alone in considering that aspect and actually, you know, thinking about the travel time and the nothingness in that respect.
Yeah. I think that it's just such a weird, even if you go to like the most isolated place on Earth, you'll never fathom like the amount of isolation there must be and just be stuck in space. And it's just like such a, oh my God.
Well, I think just how irritable we all got during COVID.
Yes, that's also true.
Right? Don't even need to
I
think
had
of
cats at home.
Just like, I don't think, what were we in lockdowns for like three months? Something like that. Like,
Yeah.
you know, 8 months is a long time.
It is.
I guess the only thing I can think to compare it to is like when you go swimming in a swimming pool and you know you can touch the bottom, it's okay. But then when you go swimming in a lake and you don't know where the bottom is, it's very scary.
Yeah.
And I feel like maybe space is a bit like that.
Yeah.
I feel like it's all right though when you're in a ship. I have like tremendous respect for people who do these like spacewalks when it's literally the suit between them and nothingness.
Oh, I'd never really considered that.
And they have like an umbilical cord tether.
Yeah, I
back
felt
to the
sick
ship.
as you said that.
Like, it must feel quite liberating at the same time as just. I don't think you can sit and think about it for too long. You know, the fact they've got work to do probably is the grounding that they need.
Claire, you mentioned something about a cosmic distance ladder.
Yeah.
Do you want to...
So I mentioned parallax already.
Yes.
So parallax forms part of what we have in astronomy is the cosmic distance ladder. And this is all stemming from kind of like wanting to find your place in the universe. And that...
Oh, that's very metaphysical.
But it is. It's like just, I mean, I love astronomy because it's such an old science that you get cave paintings and everything that shows that people have been considering their place in the universe for a long, long time. And so there's always been that drive by at least some people to figure out like the scales of everything. You know, you can see the stars, you can see the sun, you can see the moon, for instance. Like how far away are these things? Like how big are these things, therefore, that kind of thing. And there's different ways in which we can do that as astronomers depending on how far away the thing is. So parallax is really useful for nearby stars. Anything that can move relative to a background. So you've got nearby stars, you've got faraway stars that are providing that near and far background. Or you've just got static galaxies that won't be moving parallatic distances really, or measurable parallatic distances. But when you've got like your solar system objects, for instance, like the way that we found, or you know, the most precise distances to the solar system objects is through like radar ranging. So you can fire off like a radio beam towards Venus, for instance, and observe the reflections, and the distance or the difference between the time of like the emission and the receiver is then the distance between you and Venus doubled. So you just need to halve that in order to find out the distance with Venus. Radar is always a little bit tetchy. You know, you get a lot of dispersion. So the wave that you sent out, then kind of, if you imagine like with water waves, the wave will spread out. So the signal that you receive is a lot weaker than the signal that you emitted.
Yeah.
You can allow for that or account for that by shifting to shorter wavelengths, but then you need for the thing to still be reflective and not absorb the light.
Yeah.
So for instance, when you got your astronauts on the moon, they left reflective mirrors, reflective coatings, and so you can actually use like laser reflections to these mirrors on mirrored surfaces like on the moon to have like more precise distances to the moon. But obviously that's not then possible for things further away than our nearby stars. So you've got kind of like you're getting what is called a distance ladder is because you're getting further and further away, and you've got all these different kind of tools in your arsenal to use to figure out the place of you, but also them in the universe. So you're looking at the understanding that we have of stars during their hydrogen burning phase. So a star's light all comes from the fact that it fuses the lightest of all the elements, hydrogen, into the second lightest of all the elements, helium, and that kicks out a lot of energy, and so the stars can shine. And while they're doing that, before they run out of hydrogen, they exist on what's called a main sequence. It's just, it's where most of them lie, so it's just been labelled in this plot as a main sequence.
Yeah.
But if
Nondescript main
exactly,
sequence.
it's just main sequence. It's not one of the funny areas that some other stars exist in. And on this particular plot that you can draw up in astronomy, the main sequence is almost like a diagonal line across this plot. And so, it has like various like measures in there. And so if you observe a cluster of stars, they should have different masses. So they should produce like this diagonal, and the distance is the unknown, and the distance will settle it onto where that diagonal should be on this plot. So you then have a different way of measuring the distance, not to individual stars, but to clusters of stars, which tend to be a little bit further away. And then even beyond that, you get into like your nearby galaxies. And for there, you're using a result that some astronomers did in the turn of like the 1900s. The most well-known person who did this is like Henrietta Swan-Leavitt, and she noticed that there was an empirical relationship between the brightness, the brightening and dimming of certain stars, and the distance that they were away from us. So there was this like period luminosity relationship is how it's known. So that allowed us to then calculate the distances to some of the galaxies that these other stars were being found. Because these stars are so bright that you can see them in other nearby galaxies.
Okay.
And then going even further than that, you've got the fact that when a certain or above a certain mass threshold of stars, how stars die then becomes important.
Yeah.
Okay, so if you've got a star that's greater than about 1.4 solar masses, or times the mass of the sun, then it will go supernova. So the way it ends its life is through a supernova. Stars lower mass than that, like such as our sun, they won't go supernova. They won't go out and die in like such massive dramatic fashion.
Subdued, demure.
Just fade away.
None of this dramatics for us.
Look at her over there. Such a show off.
But if you've got a star in a binary system where you've got two stars close in orbit to one another, and one of them is lower than 1.4 solar masses, but the other one is slightly larger, then as that star dies, it'll swell, and you'll get a mass flow from the other star onto this like lower mass star. And when that star then reaches 1.4 solar masses, it will go into the supernova. And that kind of supernova is called a type 1a supernova. And because it happens at specific mass, we can deduce the luminosity of that and therefore the distance. And so I think I've mentioned like the word luminosity a few times now. Like, so luminosity is like intrinsic to the star. It's the power output of the star. Whereas then what you measure as the observer is flux. So it's that power output of the star spread over the entire volume of sky that's between you and that object. And the difference between those is related to the distance, because that volume increases with how far away you are from that object. So you measure a flux, you can determine its luminosity by knowing that it's a type 1a supernova, so you can extract the distance. So that again, you've got another rung in your distance ladder. And then you get onto looking at slightly further away galaxies. There's a relationship between the rotational broadening of a line, an emission line from a galaxy. Tell me which of those statements or which of those words I need to explain, and then I'll go on to the
Just do all of them.
Okay?
Yeah, I'm sorry.
Wait, just imagine that we're 7 years old.
Okay, so if you have just a light bulb in front of you, it's
Yes.
emitting white light, so a full spectrum of colours, but it's peaking at a colour that we see as white light. If you just have it stationary in front of you, you're just going to see a white light. Now imagine we can rotate it. So one side, and we're rotating it sufficiently so that one side of the light that's coming from that light bulb is redshifted.
Yep.
And the other side is blue shifted. Similarly to when you have like police cars coming past you, you have the kind of like compression of the wavefronts coming from those police cars. It goes ee, and then it goes away from you. There's an extension of the wavefronts.
Yeah.
Goes, woo. Okay.
Great impression.
Is that one's like the Doppler effect?
Doppler effect.
Yeah.
Exactly. Yeah. So the same thing happens with light. You get redshift and blue shifted rather than the ew. Okay. So when you have galaxies are all in rotation, like spiral galaxies are all in rotation. So one side of the galaxy will, the light that it's emitting will be redshifted. The other side will be blue shifted as it's kind of rotating towards you or away from you, depending on which side of you, one side of it you're looking.
Yeah.
So what happens is that when you kind of capture the light and you or put it through a prism, so you spread it out, the amount of light that you get from the galaxy will not be just at a single wavelength, it'll be spread.
Yeah.
You'll have a width to the feature that you see, or the signal that you see from the galaxy. And the extent of that width is then related to the total luminosity of the galaxy. And that's just a statement I'm going to make.
Great.
So again, you got the luminosity, you receive a flux, so you can extract the distance from it as well. And then as far away as possible, you're then looking at like Hubble distances. So this is where like the Doppler shift like comes into its own, because you're looking at the expansion of the universe itself. So you can determine the distance away you are from like far away galaxies, because the light takes so long to get to you. It itself is redshifted because if you imagine like baking a cake, you know how a cake rises in the oven.
Yeah.
So at the start of when that photon, where those photon packets of light kind of left the galaxy, was at the beginning of the baking, and then the universe has swelled up like that cake, and so it's had a further distance to travel, and so it's got stretched during that process, and so it's been kind of like. It's been stretched, it's been redshifted. That's the easiest way I can think of to kind of think about it.
Yeah, that's amazing.
That's cool.
Yeah.
So just because you spoke about like red light a couple of times, is like a red dwarf and stuff like that, is that another sort of type of star dying in a specific way?
So red dwarfs are a main sequence stars. They just refer to cooler stars. So temperature.
Cool. I was going to say cooler, like temperature.
Sunglasses. You always see them with sunglasses on.
Yeah, dead cool.
Yeah, so the temperature that a star has, it then determines what colour you see it as with the naked eye.
So it could be the same mass, but it's...
So the temperature and the mass is kind of interdependent while it's on the main sequence as well. So that plot I was mentioning with the like diagonal as the main sequence, that's called a Hertzsprung-Russell diagram. It's named after two people, Hertzsprung and Russell. Can't remember their first names. And along the bottom axis, your x-axis is temperature, and on your y-axis, the vertical axis, is luminosity. So your temperature tells you it's kind of synonymous with mass, but it's measured using colours.
So this is a daft question. If you have red shift and blue shift in light, does that mean you also get like blue giants or whatever?
Yeah, blue giants.
Oh my god!
Yeah, that's exactly it. Yeah.
Oh,
So
I feel so clever.
Down one end of the main sequence are your red dwarfs, and up the other end are your blue giants.
Oh my god.
Yeah, I mean, you know, astronomers are notorious for naming things as they see them. Okay, so we have the very large telescope and the exceedingly large telescope. There's an XKCD cartoon of like whether astronomers will run out of superlatives as they're building telescopes and what they'll do then.
What's the critical mass of size we can think of to name our telescope? So I wanted to come back to luminosity because you mentioned quite a lot of times now, and I think I'm wrapping my head around it. So essentially, you're talking about when things go supernova, they emit like a certain amount of light, and because they go supernova as a particular mass or size, is the luminosity from that constant then, and therefore you can do the calculation, or is that based on something else?
So the luminosity full stop is not necessarily associated with supernova.
Okay.
Just so luminosity has the same units as power. So if you want to think of it as power, you can think of it as power. Okay. They're all measured in watts. So you've got like an intrinsic power output of something that is emitting radiation or has, some kind of energy output. So in our sense, radiation is then the photons. That's what we're thinking about. And so when you take a star like the sun, when it stops burning the hydrogen into helium in its core, it will evolve off the main sequence quite gently. It will have a nova phase, which is the same name as my cat. What results from a star like the sun dying is a white dwarf. Now, that was what was in that binary system with that larger mass star. That's a good starting point.
Yeah.
So that larger mass star is then kind of loading some of its mass onto this white dwarf.
Yeah.
And so this white dwarf is growing in mass. And we said that there was that 1.4 solar mass limit to, when you would go supernova or not. That still applies when something's not a main sequence star.
Mm-hmm.
So it's that mass loading onto a white dwarf that suddenly goes over that limit and suddenly goes boom.
Yeah.
And at that point, the luminosity is very large.
Mm-hmm.
If something went supernova in a nearby galaxy, we'd be able to see it.
Mm-hmm.
The star Betelgeuse, which we can only say once. Well, definitely not 3 times.
I was thinking the exact same.
In Orion, that is due to go supernova, and when that goes supernova, you'll be able to see it during the daytime, not just the nighttime.
Wow.
So there's a massive luminosity increase, a brightness increase.
So it would be like having a second sun.
It'll still take up the same kind of amount of light as space in the sky, and Betelgeuse is not very big. It's just you'll see that point of light during the daytime, in the same way that you can see the crescent moon in the daytime.
Okay. I was thinking apocalyptic.
No.
Okay.
No, we're not kind of going all encompassed by a supernova. No.
Yeah. Okay.
This is how Claire tells us the world is ending.
Yeah. I was like, oh my god,
supernova, and we're all gonna die, everyone.
Yeah. Do you know? So my first tattoo, I've got the Orion constellation.
Oh, fantastic.
On my hip. Yeah.
Oh,
so,
fantastic. The full one, or just kind of the bow tie shape?
Oh, it's kind of like dots and lines.
Yeah, but is it just kind of the bow tie stars, or have you got
he's
the
got
full
he's got the arms. He's got the arms.
Okay, cool.
Yeah.
Because this is another bane of my life. It's not kind of a media representation, but it's just access to dark skies. Most people's concept of what stars are in Betelgeuse is just that bow tie, because most people live in cities, and that's all of Orion that you can see.
Yeah.
It's just that bow tie shape. You can't see him holding up his hammer axe or whatever behind his head. You can't see him with the bow in front of his arm.
Yeah. Having lived quite a few different places, you sort of notice the different amount of light pollution, and it makes me really sad as well. Because part of why this is a bit emotion, why I got the Orion tattooed on me is when I just feel it's a home point, I used to walking home of an evening after a night out on the town, and you would see Orion above my house, and then having moved different places away from my childhood home, it felt like a connection. And then sometimes in the city you can't see it so much.
And the cool thing about astronomy is I know which months of the year that's possibly in.
Yeah.
Because Orion's not up in the summer.
Yeah. Be the Christmas holidays, stumbling home. Yeah.
Instead, during the summer, we get to see Scorpio instead, because the whole the constellation myths and stuff is something that fascinates me as well.
Yeah, I quite like it because I used to be really into Greek mythology.
Yeah.
I probably still am now.
So the scorpion killed Orion, so they're at opposite ends of the sky. So
really?
they can't continue the fighting.
Oh, because I also have Canis Major and Minor tattooed on me because they're Orion's dogs.
Yeah.
My mum's gonna hate this again because I'm gonna say something about my mum. But I got there's a microscope constellation which I think is in the southern hemisphere. And then my mum was like, there's not a microscope constellation. That's just made up, Eleanor. And I was like, Mum, they're all made up.
They're all made up. Yeah.
No, they're just dots that people have decided to put into shapes.
One of my favourite things to do with, this is going to sound strange when I say it out loud, one of the favourite things to do with young people, and that's in a science communication sense.
Outreach,
outreach,
don't worry.
thank you. Is I've got these little worksheets that I've created. Because you can download the positions of the stars, and so you can make kind of just maps of the areas of sky. So there's no constellations drawn on it. It's just an area of the map of the sky.
Yeah.
And what I do is I tell them about some kind of star lore. So you've got folklore, you've also got star lore, which is the constellation mythology of your different peoples around the world at different times. Tell a bit of star lore from some kind of culture, and then invite them to find their own constellation in the star map, and create their own story around it. Now, it's thrown out some amazing ones. There were a group of brownies that I did it with, and they would all picked they'd found love hearts that they could draw because one of the people around the table had a crush, So the story was all about this this little lass
That's
was
so
like
cute.
really red faced, so embarrassed as they were kind of like telling this story because she'd of course like told her mates the story, but then everybody at the table kind of told it for us, like you know.
That's such a mean thing to do to your friends. Here's this random person who's going to teach about the stars, everybody. My friend's going to crush on someone. I'm going to write a story about it.
Yeah, and then we also got some weird ones as well. So I've done it at like science fairs where you're not always interacting with the people who come. Like so that, and we found at the end of the day somebody had written in a help constellation. They'd found the word help amongst the stars. We were like, this feels like something we should have noticed during the day.
Oh god.
So I've kept that one just as a warning to if people use that again.
Yeah. Or as like evidence.
maybe
like,
maybe it's worth keeping. Yeah.
Yeah. Just in case. Ooh.
So I'm going to bring us back to our like beginning topic a little bit, if that's okay.
Is that Star Wars or?
Star Wars.
Okay.
So as someone, you know, as sure we all grew up with Star Wars, etc., and I as someone who had a massive crush on Han Solo growing up because I was. You know, he was beautiful.
Human. You're
he
human.
I'm human. Who can look and not see an Adonis in that man? Anyway, he's a scoundrel.
I'm raising my hands
I know.
just for the
It talks to the
lesbians at home.
bisexuals, the chaos bisexuals. So if they were going to sort of rewrite, or you were going to rewrite that scene in terms of Han Solo talking about
how
like
do you make
how do you make it like
statement accurate?
Yeah, and like what kind of units and what kind of, I guess, realistic time, if we're going to use time as the measure, or if we're going to adjust parsec to mean something more reasonable. Do you have any idea about how we could fix my man?
I don't know, like Star Trek like overcome it by just using warp speed, don't they? So they've kind of like made up their own unit. We've got you've got fighter jets using Mach speed. For instance, the average Joe on the street's not going to know what the Mach number means.
No.
I can't remember what the Mach number means. It's something to do with the speed of sound, but yeah, I can't remember what.
Something more achievable than the speed of
but
light.
You could surely have like some version of Mach speed that, you know, can be a fraction of the speed of light or something. And that could have just been explained, I'm sure, somewhere in the cantina.
Yeah.
You know?
Yeah.
So just get a diagram out. It's like, hi guys, I'm going to explain to you the units of time that we use.
So my dad does, we were talking about this, I saw my family at the weekend, we were talking about, my dad does pub quiz on the regular, he's on a league and everything. And one of the questions that came up was, which is the planet with all the rings on it? And we were saying, you know, pub quiz, you do kind of have to scale back your expectations. He said Saturn, basically, as his answer. But then I was like, we both sort of said, I feel like there's other planets that have rings or like ice fragments going around. So I don't know, could you confirm or?
Yeah, I know that Uranus definitely has rings. I've seen them. I can picture a photo or an image that JDRST has taken pretty recently. And the interesting thing about Uranus is that it rolls around its orbit rather than spins.
Oh wow!
So
The
marble.
Its rings. Its rings are north south rather than east west. If you imagine like compass points.
That's adorable.
Could you ever stand on Uranus?
It's an ice giant, so it does have a surface somewhere underneath its atmosphere. I'm not too sure it would be a pleasant experience.
That was the follow-up question.
And whether you
Would
feel
you
like
be
you're
sick?
standing or whether you feel like you're being crushed is another question, because it's the force of gravity will depend on like the mass of the planet, and it's several times more massive than the Earth. I don't have the figures in front of me.
Why not? Why not, Claire?
But it's known as an ice giant. Giant would suggest that it's bigger than the Earth.
Yeah. Once again,
it's not quite as big as the gas giants of Jupiter and Saturn.
These naming systems are
As I
coming
told
in
you, it's just
Yeah.
say what you see, say what you see. It's like we should go on catchphrase. We'd like be an expert like population.
Yeah, you would,
catchphrase.
actually,
Yeah,
yeah.
so they put up a small red dwarf,
Yep.
a big blue one, blue giant.
Yeah, exactly.
Win it.
That's
Take
the
home that
Extremely
prize
Large
money.
Telescope.
I have a question.
Yes.
And again, I'm going to bring us back to Star Wars because I don't know what else to talk about. So one of the things that often gets criticised in films and TV shows about space is how explosions work in space.
Yeah.
Ooh.
So can you talk us through like what's wrong with how they're portrayed and what they might actually look like?
I think it's that problem with like here on the Earth, like anything that you can't see, you just assume is just nothingness, right? So the air around us would be nothingness, but it's not nothing. It's, physicists would describe it as a fluid. So things that impact that fluid, like explosions, the fluid reacts like a fluid. So if you drop something in the ocean, even if it's just, a splash of water going from a tap into the pool of water below it or something, you can see a ripple effect kind of thing. And then so that dynamic still applies to the air. You've got this fluid dynamics, it's the field. But in space, there's literally nothing. There's no fluid. So
because it's a famous alien tagline, isn't it? In space, no one can hear you scream.
Exactly. Yeah. There's in the sense for sound, like sound travels between you and I because there's air in the way, and that air is impacted. There's a mini explosion from my face to yours.
That's a nice way of thinking of it.
And it's just the pew, 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 all the way, like from the air that's close to me to the air that's close to you, and that travels at the sound of speed.
And I suppose, like with explosions as well,
Sound
like
of speed,
sometimes
speed of sound.
Yeah. Sometimes it's like the sort of oxygen burning up around. So if you haven't got oxygen around you to explode,
there'd be no fire or anything.
There'd be no fire.
There's not enough fuel to ignite.
So what would it just go? And that was it, or they just wouldn't explode
Would
at
it
all
be
because
like
there's no
a
oxygen.
I don't know, to be honest with you, I don't think it's an open field of research.
No,
to see.
I think we should blow some stuff up in space, Claire. I'm not going to lie.
Because you'll have the fuel local.
Yeah.
But it's then, I don't have any idea of like how that would diffuse. What shape that diffusion would take.
It's
or whether it just could be just a quick of it all being used up. I have got no idea.
I mean, obviously there wouldn't be sound, because that's the thing that they often get criticised for. It's like there wouldn't be any sound because there's no air to move, so there would be no sound. There'd be no like as something goes up and explodes. And I hope that comes through the microphone and not just me making a weird noise. But yeah, it was just, I've always wondered about like how it would like, because often you see like there's explosions going like vertically or just like fully out like they would on Earth or whatever. And I just wonder like what would a shape, or would there even be an explosion if something exploded in space?
You're still going to get, so dynamically, if a solid object is collapsing, you will still, something has to move out of the way. So you dynamically will still have ejector. So a lot of the time when we see like explosions, like for instance when the Death Star is destroyed, if we come back to Star Wars, like that is a solid object. Those solids have to go somewhere because they're being exploded. So there'll be an ejector of material, but it's that smoke and embers that I'm imagining as your question about explosion that I'm just not sure of. But everything else would move very quickly away from where it was at the point of impact and continue to move away until it hit something else or was captured by the gravity of something else. I
have to go watch Star Wars now.
That's not a bad shout, to be fair.
What about like implosions? Because sometimes I hear, because like of pressure differences and stuff.
Well, that's what the supernova are doing. So what's actually happening is there's no fuel left inside of the stars anymore. So there's nothing to support the weight of all of that mass beyond the core. So the thing implodes. And it's the forces that support matter. There's like, you can't squish material together beyond a certain point. Which halts that implosion, and that causes a bounce, like a shock wave, and it's that shock wave that we view as a supernova. So you still get shocks and stuff traveling in space.
Thank you, Claire, for talking to us about space. I feel very insignificant now, which
good. It's okay.
Yeah, no, I like it because if I fall over in front of the lecture hall, it doesn't matter because in the scheme of things, nothing
cares.
Matters. Yeah, it's very nihilistic, and I find that comforting.
I don't mind it.
But honestly,
when you're around.
Well, again, it's not about being significant or insignificant. It's about being isolated and alone in a big space, I think.
I think there's the conflating of two things there.
I feel complicated feelings about space.
The isolation's going to be quite comforting if you fall over in the lecture theatre in front of your students.
I mean, what would you fall over?
No, I mean, like, you wish you were on your own.
Oh my God, I wish I was alone in space right now.
In space, no one can trip over.
No one can see you fall.
Yeah, no one can see you
fall.
To be fair, if we were in
Perfect.
space, I think I would still fall over somehow.
You would find a way.
Yeah, thank you.
Final frontier.
Yeah.
Segueing beautifully from talking about being insignificant to some very significant topics.
Oh, very well done.
Yeah, I know, this was good, right? It's almost
Yeah.
like I planned it. So yeah, your significant work and contributions, I guess, to the LGBT community in Exeter, and I don't know, just your queer life, or however you want to start this portion.
Yeah. Well, once upon a time, there was a baby gay.
Aw.
Nah,
And she was all of us.
but mainly me.
Yeah.
The big thing I think that you're alluding to is the Prism Exeter stuff.
Yeah.
And just because this is only going out on audio, that is prism as in the triangular piece of glass,
Yeah.
and not prison as in the place you go to jail.
Yeah, I have to clarify
Yeah.
that so often.
I never thought about that when we
it's
chose the name.
accents.
No, we were sitting around a table and we were like, there's an organisation that does something similar in South America and they call themselves Prisma. Prism's quite nice. Let's
Yeah,
So,
I like it because it's the refraction of light
Yeah.
makes the rainbow and like
Exactly.
perfect.
Yeah.
It's on brand.
Yeah, and the
yeah.
triangular piece of glass allows us to have the delta symbol for the change that we want to see
Ooh.
in the logo. Did you not know that?
No.
No.
You got to remember, I'm not actually that clever. So
I don't think that's part of it. You just weren't around the table, and I forget that.
no,
It's like it's insider knowledge now. We're
Yeah.
in the clique. We know that's what
I
it
know
means.
the secrets. That is very cool.
It's
So-
a maths joke.
Oh no, that sounds nerdy now.
Oh, like it didn't before.
So you do you're the founder of
Yeah,
Prism.
yeah. The person who came up with the idea, I think. Yeah, there was
Yeah,
like,
the head
certainly- certainly like needing the support along the way.
Hmm.
I won't say there's been like just myself driving it forward. I feel like it's just fallen into a space that people have been very accommodating of, and it's just run away from me almost in how it's kind of carried out. So I found myself being the only person from like the Southwest who was going to the nationally organised LGBT seminars that happened
Yeah.
from around about like 2016.
Yeah.
No, it might have been earlier than that. But it's, 2015, 2016, something like that. And I don't know how much of that was because the first few were organised in like Sheffield and York. And like, for me, that was an opportunity to go visit my parents.
Yeah.
And I just spoke to my supervisor and was like, I'm going to take a few more days off close to the new year. And I didn't say where I was going or anything. I was just like, just not going to be here. Going to be staying with my parents. And that was an easy way of kind of like getting there.
Yeah.
So I don't know if I had like that as an advantage of being there, but like recognising that there didn't seem to be anybody else from like the Southwest, I was like, this is really useful for me. This is a proper recharge space, and this is the only space that I have on an annual basis to see and speak with other LGBT people in STEM. So we've got like science, technology, engineering, maths and medicine kind of included in there. I was just like, this deserves to be something that more people know about. I can't be the only LGBT person, within STEM, within the Southwest or anything. That wasn't possible. I knew that there were like other like PhD students. For instance, I was a postdoc at the time, so other PhD students in my even like research group, who were themselves LGBT, different degrees of out, but we'll get there anyway. So it was just kind of that thing of like, well, how can we get that down in the Southwest?
Yeah.
And also seeing kind of like, it's that ability to kind of like see how somebody else is doing something and what you feel it's missing. And I thought having that local aspect was really useful, like having like more of a sense of community. We'd forged a community, but that community only came together once a year. And for the rest of the year, it was an online community if people wanted to be part of it, or kind of like put in the effort to keep it going as an online community. I'm not really an online person. Community for me is in person. It's I don't really get any strength from an online community because you have to wade through all of the noise that's happening elsewhere online in order to get to that community. And I just prefer in-person community. So back in the end of like 2017, spoke with the Institute of Physics, their Southwest branch. They were having like an open meeting in Bristol, and people could come along and kind of just attend the meeting. So I submitted like an AOB to the meeting, got invited to come along to the meeting, went up to Bristol in person. They paid for my transport and everything, so I was attending an Institute of Physics meeting.
Yeah.
I was just like, how about we go to Exeter Pride? Exeter Pride is like really family oriented. At the time, they used to have like space in the space behind Exeter Library as well as on Northern Hay Gardens. So it's like kind of like lower area. I think it's called Rougemont Gardens.
Yeah,
Yeah,
as well.
accidentally got locked in there this year. Yeah.
Yeah, so, and that used to be like the family area of Pride, whereas the rest of it was kind of like all the music and that stuff. So I was like, we could have it in the family zone. There's a load of people with families and their kids and kind of come across, and one of the Institute of Physics' main aims is to interact with girls under the age of 8 with physics.
Yeah.
Because it's at that age that people start being discouraged from following mathematical subjects, physics included. So if you engage with people at that age and repeatedly engage with them through like puberty and adolescence, then you've got a greater chance of them continuing into physics. So it met with that core aim of the Institute of Physics. So they were like, yeah. And how about in exchange we co-opt you onto the committee for the Institute of Physics? So there was a little bit of bargaining there, and this is a tale that kind of continues on with like Prism like all the way through. It's kind of like, what can I get to happen, and what do I have to do in exchange?
How many pieces of silver do I want?
Yeah, it's how much back scratching is involved to myself get that back scratch. And it's just that kind of. I like that exchange of work. There's not necessarily like a transactional exchange that needs to happen. It's kind of you could be useful for us and I can be useful for you, etc. Yeah. And I think that is how the world works, really. Yeah. So yeah, they supported. They paid for the stall. They recruited volunteers. It was really easy to put like the call out to volunteers. We got people just outwardly volunteering to come and like staff the stalls. So we had people from the Met Office who I don't necessarily think would describe themselves as physicists, but found out we were doing this and came along and volunteered on the stall. Somebody from Network Rail, who I know because my partner's dad worked within Network Rail, and she at the time led their Archway, which is their LGBT group.
Oh, that's cute. That's another cute one.
Yeah. I thought that's really nice. So they're like local branch of Archway, because obviously Network Rail is a UK-wide thing. Yeah. And she was similarly kind of like finding a lot of the work that was happening was concentrated away from the Southwest. So for her, like she didn't know about like the LGBT seminars, but all of Archway's work, like the closest they would get into Southwest was Bristol. Yeah. So they wouldn't be supportive of the people living in Dorset, Devon, Somerset, Cornwall. You know, it's a 2-hour round trip to get up to Bristol, or 3-hour round trip to get up to Bristol, I should say, when the traffic is good.
Yeah.
So
and
if you're going for an evening social,
not like
from Exeter,
not further south.
The community again was there in principle, but not really touchable.
I do think one of the things about the Southwest is like the sort of lack of closeness and infrastructure I've noticed compared to living in other places. Because like before I moved down here, I was living in Coventry, and like you were like a 10-minute train ride away from Birmingham, and just like the amount of people. Yeah. So I don't think it's necessarily that there's like less representation or like a less diverse population. We're just very spread out with terrible train lines that are next to the ocean, get shut off every so often. Like,
bad roads as well.
Bad road. The buses are. I think it's really good to have something that sort of like you were saying is local and brings local people together. Just like with Prism, you have reach beyond just like the things that are specifically in the library or anything. Like there's more ways to engage, and I think it's really powerful.
Yeah, because the connection then immediately with the Met Office and Network Rail meant that we'd filled a gap that I thought was missing from the LGBT seminars, which were predominantly, if not just, academia. Yeah. And as a postdoc at the time, part of what was going through my mind was like, where is my next job? Like it comes back to that like precarity of like academia as a career to get into. Yeah. You're always looking at where to go, and I think as an LGBT person, when your only experience of the big wide world is universities, there's often this kind of like you get drawn into that narrative of like universities are a liberal place. Is the grass going to be as green if I leave? And there is kind of like a reinforced like comfort, even if you don't feel comfortable in the environment. There's like I don't want to leave because what other else it will be unknown and therefore is uncomfortable.
We've mentioned it before about academia being like a sort of a bubble on its own in terms of, you know, universities are generally quite liberal places. They're generally quite...
It's coming to the fore more so now that the research excellence framework, I know we're getting like really technical now,
Yeah.
but the research excellence framework's more focused on research culture.
Yeah.
Through its entire like people, environment and culture section. And so that whole element of like that thought process of postgraduate students and postdocs considering their next steps, that is all part of like the research culture thing. So we were thinking about that before it's become a focus of the research excellence framework. So yeah, I think that's just a natural thing of like navigating the world. You're always conscious of where the sharks are. And so having conversations with people about their experiences in their sector, in their with their employer, that kind of thing, and seeing not necessarily like where there aren't sharks, but how the sharks manifest in different spaces. I think there's been quite a lot of like crossover experience, but also like some stark differences. Like certainly as an engineer in certain places, they're subjected to different experiences than I've experienced, for instance. So I won't speak for anybody else, but there's a whole wealth of experiences that have been shared across the Prism talks over the years. But yeah, we came out of the Exeter Pride with a bunch of stall volunteers and then stall visitors who had expressed during the day, over the course of the day as I'd been chatting with people, an interest in having a community for LGBTQ plus people in STEM. And we were all kind of geared towards what was going to be the first International Day of LGBT people in STEM, which was going to happen that year, 2018, on July 5th.
How long it's been going?
Yep.
Oh, wow.
So the first International Day of LGBT people in STEM, it was set up by Alfredo Carpenetti, who founded Pride in STEM.
Yep. Familiar name.
Hats off to him for getting that all organised and everything. It's since like moved date. It's now November 17th.
Yes. Yeah.
But that first year, I don't know for how many years it was on July 5th. So we had a meeting in the offices above Exeter Central Station, so the Network Rail offices, and had a bunch of people, a few people I managed to drag along from the physics department because they were within reach, so I could physically drag them.
You are coming.
Yeah.
Nothing to say about it.
We got somebody from Tech Exeter who's remained like the best ally all the way through this. Total support from him. We got somebody from the Science Park straight off the bat, who brought, like, because she's quite a senior person there, she brought her effectively contacts list and was like, if there's any kind of like person you want us to source, let's have a look if they're in here. You know, that there was that immediate kind of like connection to the local business community that way. And we just had this idea that we could do something similar to what Pride in STEM had been doing with their Outthinkers series, where they'd got somebody to talk about partly about their research, partly about their experiences, but we could run it 3 times a year. Initially we were trying for 4 times a year, but as a postdoc, Septembers are fine. As a lecturer, Septembers are awful.
They're the worst.
Tell me about it.
So we now try and do November for International LGBT Day of a day of LGBT people in STEM. They need like a shorter, catchier like phrasing for that. LGBT STEM Day, I suppose, kind of works. February for LGBT History Month, and then June, July for like Pride Month / our birthday. With the speakers event.
Yeah, I think it is because something that you've sort of done a couple of times now is like the queer science competition for young people to enter. I don't want to put words in your mouth, but the idea is sort of championing sort of role models of LGBT people in STEM. And I know sort of on the leaflet that you had last year or the year before, maybe it sort of said like, beyond Alan Turing, a lot of people can't really name anyone. Which is, okay, Alan Turing's great and nothing against him. But I think, a lot of the sort of LGBT role models that we have do tend to work in the arts. And I think it is then hard if that's not the sort of career you want to pursue or that's not the talents that you have, you do sort of get this feeling that, like, you know, maybe there's no place for LGBT people in STEM. And Alan Turing's not exactly a happy ending to the story, which is the other thing. So it could even put people off. And I've had similar feelings with sort of dyslexia as well. Like, you don't get very many role models in STEM. So I think it's really important, this sort of role modelling. And I know that's something that you're really keen on as well.
It arcs back to the Section 28 repeal. I know it's been mentioned on the podcast previously, but the repeal of Section 28 happened 20 plus years ago now. There hasn't been any further legislation to teach in. We've stopped the banning or the promotion of homosexuality as a pretended family relationship, as it put it. But
I think I did that voice as well.
Just making sure that it's not my voice.
No, of course not.
You know, there's been the responsibility of teaching in LGBT identities into the curricula has fallen on LGBT charities. You know, shout out to Schools Out UK, to Just Like Us, to the Proud Trust, who are doing work behind the scenes that creates resources for school teachers to use on this regard. But there's still a lot of hesitation to just mention that somebody is LGBT. In the same way that, you know, you can drop into conversation, it's natural in conversation to say somebody's pronouns when you're describing them.
Aye.
So you always drop gender in, or binary gender into the conversation when and it's predominantly he within the physics. Right?
Oh no, same with biology, don't even worry about it.
Yeah. And if you can throw up a picture, that picture might give you a hint towards somebody's ethnicity. It might give you a hint towards visible disabilities.
Yeah.
But you have to be specific to teach in LGBT identities.
Yeah.
And so it's trying to gather ways in which either, well, the competition was because that's not been done in schools. There's not been the provision of LGBT role models within the sciences. If you look across the educational charities, you know, resources, there is one for Key Stage 3 and 4 maths and science. And that is measuring the area of a pride pitch. But it's showing an example of how it could be taught into the mathematics curriculum, but it's not giving any role modelling.
No.
Yeah, it's not going that step
There's
further.
an absence of role modelling. So it's not like you can say, well, we're studying, for instance, like genetics or microorganisms today, so we're going to mention the work of, for instance, like Ben Barres. You know, it's not saying that, it's not teaching it in that way.
Yeah.
So what we did with the competition was also twinned with the recognition that we weren't getting many under 25s, under 21s, like along to the speakers event. So there had to be something else that gave this community to young adults. And so we provided some like getting started resources, but we asked secondary school, college and university students to research for themselves LGBT role models, LGBT people in STEM, and for them to tell us why they found them inspiring.
Yeah.
It wasn't just like, who is this person? It was like, why does their story matter to you? And it was all kind of stemming from that idea of like, as educators, we work towards the thing of like co-creating things with students. It's no point telling somebody something. It has to be something that they can attach themselves to, that resonates with them. And so that was all designed to give us a co-created material to carry forward. We could see what inspired students, and then what we are doing at the moment with Schools Out UK is creating resources that will go into schools and queer the Key Stage 3 and 4 maths and science curricula.
Yeah.
And that's all with the backing of like 3 different versions of this competition, the queer science competition.
That's amazing.
So for the last version of the competition, which was a year last February, when LGBT History Month had the theme of medicine, like Chloe Orkin is the person who was championed, and it sings to her disability activism, as well as her LGBT activism, women's activism.
Yeah.
And there's various other people who are going to be like celebrated through the posters. Yeah.
I just think it's such a lovely thing that you've created for like children and adults across the Southwest. I think,
So obviously, as the coordinator and lead of Prism Exeter, have you done a lot of like, apart from the LGBTQ in STEM things, had you done a lot of like public engagement and queer rep stuff before before that?
No queer rep stuff. But yeah, I've done public. Well, I suppose public engagement is just a natural progression from like ambassadorial roles that I was always thrust into. Like very few women do physics, and like I can talk to people. So like my school would pick me out as one of the people to volunteer on like the open days that you have at like school, and like demonstrate some like science or physics or whatever. Like I remember one of my classmates like warming maggots underneath his tongue in order to like race them, because they would race towards a light and you could explain like the light and stuff. At St Andrews we had an inflatable planetarium.
Oh, was it bouncy?
No. So you
just the surround is inflatable.
You put a fan inside this like igloo, effectively the
Yeah,
cloth
yeah.
igloo,
Yeah.
and the fan is sufficient speed to inflate the cloth igloo.
Okay.
And then you set up a projector in the center of it, which is a special projector. It's effectively a light with a cylinder, black cylinder with some pinholes to mark out where the constellation are. And because it's inflatable, you can then pack it in the back of a big car, and drive it to. So we drove it to local primary schools, and I say local. We were up in like Aberdeenshire and up by Inverness, like so we were travelling quite a lot of Scotland, taking this mobile planetarium around. So we do like stargazing nights like that, but inside. But my favourite version of that though was when I'd secured our link to Dundee Science Festival through the Dundee Science Centre that's there, and so we were set up in like a community hall somewhere in Dundee, and we'd done like a few shows already. They were timetabled into the evening. And we got a request that a deaf group had arrived for the science festival. You know, was there any way that we could give them a tour? And so like the three of us who were running the show, we just had a quick like heads together. It's like, how can we make this work? One of them had ridden on their bike, and so we realised that we could illuminate them with the rear bike light. So with a red light, so we could illuminate the interpreter, the BSL interpreter, with the red light. Then we worked with the BSL interpreter to figure out how we could work with her to figure out when the audience were looking at us. So they knew where to trace the laser pointer if we were drawing things out, and when they knew when to look at the interpreter themselves to have what I was saying relayed to them. And it worked fantastically, and just that kind of wish to kind of include people. We'd figured out already that because the thing is like an inflatable sheet, you could lift it up and put somebody in a wheelchair underneath. Like, so, you know, it wasn't that everybody had to crawl inside. You had ways of kind of getting like accessible seating effectively inside as well. And it was just a joy to kind of have just that immediate kind of thing. Yes, we will make this happen. And like, I mean, I talk quickly, this is obvious from the podcast, but knowing to kind of like slow down the speech and being talked to by the BSL interpreter to kind of just slow down, and her instructing how we could make it work and everything was absolutely fantastic. So there's not been that kind of queer engagement, but there's always been an EDI push with whatever I've done, or kind of like just an inclusive push with whatever I've done.
So, well, I guess like leading on from that, do you have any advice or any ideas for our listeners, and me as well, because, you know, I'm always looking to get more involved within my energy level, as to what things people can look out for, attend, get involved in? Do you have any ideas for people who want to be more involved in not just, you know, queer outreach or representation, but just any kind of activism or group work?
Firstly, it's like find your people. Like local to Exeter, there's different ways for like you can get involved with like the queer community. I mean, you guys as podcast hosts are looking for, you know, potential interviewees. We want to sit on this hot seat. It's very comfortable.
The room's a bit warm, but apart from that,
only because we've had to shut the windows for the noise.
The seagulls.
You know, there's Exeter Pride's always looking for volunteers. That's a great way to get involved. Exmouth Pride's always looking for volunteers. The Out There Queer Fringe Festival happened last September. I think there's been musings to have it be an annual thing. So searching for that would get you information on that, and you can also find a bunch of other community groups through their web pages as well. They've created a directory as well. But further afield, if you're an LGBT person in STEM. There's different organisations across the UK that are doing their own little bits.
No, I think like a lot of sort of learned societies have like LGBT sort of branches now. So I know like I'm part of the Microbiology Society and they have a branch now as well. So I'd say like look out within like specialist societies too, because they do quite often have things, which is nice.
We have the LGBT Physical Sciences Network across the Royal Astronomical Society, the Royal Society of Chemistry and the Institute of Physics. So I'm quite glad it has a short name. You've got OSTEM, which is Out in STEM. We were based in Birmingham. That's the UK chapter of what was a US set up thing. Pride in STEM, who are more concentrated towards the London side of thing. There's Equal Engineers, who have an LGBT branch. I feel like I've forgotten. Proud in Science. What would be useful if anybody has the capacity or the brain space to do so, the know-how to do so, is to compile a directory of all the different groups that exist across the UK, but also further afield as well. I don't think such a directory exists.
Not if they do, they need to advertise it better.
I think people are very good at sort of saying like linking up together, but if there's a global list, it has completely passed me by. This has been very nice, Claire.
Thank you very much for having me.
No, thank you for coming, Claire. Obviously, I've only met you once or twice before, so it's been really nice to chat to you via microphone. But yeah, thank you so much. I've learnt some physics. It's been wonderful. I've asked questions about space, which has been nice.
And about Star Wars.
I've always had questions about Star Wars, but I think I need to focus those to other people who make Star Wars rather than you.
Can we just stop now? Can we just stop making the TV series,
churning it out,
and the films, because it's diluting the product?
If you want to find out more information or see who's speaking and any images we put up from the podcast, you can follow us on Instagram. Our Instagram is at _serious_science. You can also follow him Prism Exeter, which is prism.exeter. on Instagram. Prism also has a Facebook and a LinkedIn. I'm not about the vibe for LinkedIn, so...
I'm all about professional.
Yeah, Claire is on the vibe for LinkedIn, look. So that's where you can follow us online and see our lovely faces.
Thank you everyone for listening. We hope you've enjoyed the podcast episode. Thank you again, Claire, for joining us and for sharing some information about Prism and all the work you do, but also obviously about Star Wars, which I enjoyed immensely. Thank you so much, and we'll see you next time with hopefully another guest.
Cue jazz music.
Bye everyone.
Bye.